All right, so we're in section 3.2 of Al Grosch's book, Developmental Math 2. We're going to talk about graphing linear equations using a table of values. First off, we're going to start with verifying a given solution. So if you look here in your book, there's an equation. This is what we call a linear equation, 2x minus y equals 10. A linear equation is an equation that when we graph solutions for it, they make a straight line. There are infinite number of solutions because we pair up values for x and y together to make ordered pairs, and the infinite solutions will join up together to make a line. So the first thing we're going to do is we're going to look at determining if these ordered pairs are solutions. All right, so the first question says, determine whether each ordered pair is a solution for 2x minus y equals 10, and this is the ordered pair, 2, negative 6. So the first value is the x value, the second value in the ordered pair is the y value, and we're going to take those two values as x and y, and we're going to substitute them into this equation. If it is a solution, you'll get a true statement. If it's not a solution, you'll get a false statement. So when we substitute 2 in for x, we're going to need to use parentheses because it's going to say 2 times 2. And then minus y would be minus negative 6. And the rest of the equation says equals 10. When I simplify all of this, does it make a true statement? So first, 2 times 2 is 4. Minus negative 6 is actually going to cancel to be plus 6. So is this a true statement? 4 plus 6 is 10, so that means that yes, this ordered pair is a solution for this equation. Let's try it again here on letter B, where we're being asked to verify whether this ordered pair is a solution. So again, this will be x, 10, and this will be y, negative 10, and we'll plug them into this equation. So we'll have 2 times 10 minus negative 10 equals 10. And we're going to simplify. 2 times 10 is 20. Minus negative 10 turns to plus 10. This is not a true statement because 20 plus 10 is 30. And that is not equal to the 10 on the right-hand side. So is this ordered pair a solution? No, it is not, because they don't make a true statement when simplified. Plug in and simplify. All right, we're going to look at this table down here. This says, complete the table of solutions for y equals 2x plus 3. Okay, so this is a different equation than the one we were working with above. This is still a linear equation. There are an infinite number of solutions. If we can find a few of the solutions, and that's what we're going to use this table for, we can, down here on the graph, line them up to find the line. So we're being given these values for x. It's our job to find the corresponding value of y, and then those two together will make an ordered pair. To do that, we take each value of x, we plug it in here for x, simplify, and that will tell us what y equals. So I'm going to try and find some white space to do that here. At least the first few, and then you might be able to figure the rest out by yourself. Okay, so y equals 2 times x plus 3. If x is negative 2, that would be y equals 2 times negative 2 plus 3. When we simplify that, we get negative 4 plus 3, which is negative 1. So y will equal negative 1. And this will make an ordered pair for this equation. Negative 2 for x, negative 1 for y. All right, so we're going to go to the next one. If y equals negative 1, we'll have the equation y equals 2 times negative 1 plus 3. X equals negative 1. So that would be negative 2 plus 3, which is positive 1. So this would be a y value of positive 1. The next value is 0. We'll plug it in for x. So we'll have y equals 2 times 0 plus 3, which is 0 plus 3. So y equals 3. And then we have x equals 1. So we'll plug in 1 here. So y equals 2 times 1 plus 3, which is 2 plus 3, which is 5. And further on down, we'll have y equals 2 times 2 plus 3. 4 plus 3 is 7. And y equals 2 times 3 plus 3, which is 5 plus 6. I'm sorry, 6 plus 3, which is 9. So those are our ordered pairs. We have -1, +1, 0, 3, 1, 5, 2, 7, and 3, 9. And all I did was take these values for x that we were given, plug them into the equation, simplify to figure out the y, and then these two values together make an ordered pair right here. So we have 6 ordered pairs that are solutions for this equation. Of course, like I said before, there are an infinite number of solutions, so those are just a representative amount. And when we can find that many, we can figure out where the line will be. So now it says to graph these points. This is the same equation, so these are the points they're asking us to graph. So let's see. -2, -1 will be down here. Right there. -1, -1. Okay, this is not right. -2, -1 is here. -1, +1 is here. 0, 3 is here. 1, 5 will be there. 2, 7 will be up there. And 3, 9. And you can see they do line up in a straight line. I have a line tool here. Let's see if we can get it to work. I don't know. Well, that's not really. Well, that almost hits all the points. This tool doesn't work very well. I don't like it. That's not good. All right, let's go to the next page. Well, maybe I can freehand this line. There we go. And of course, we put arrows on the end of the lines to indicate that the solutions go on infinitely. All right, on this next page, we're going to do the same thing. We have a new equation, 2x minus 3y equals 12. This time we're given some values for x and a few values for y, and we're going to complete the table. So we're going to first plug in 0 for x. And I'm going to scroll over and zoom so I have some white space here. So that will be 2 times 0 minus 3y equals 12. Well, 2 times 0 is 0, so we don't need that term anymore. So this turns into -3y equals 12. When you divide by -3, y equals -4. And then we're going to do y equals 0 from here. So we'll plug it in this time for y. So we'll have 2x minus 3 times 0 equals 12. And again, 3 times 0 is 0, so that term is just turning to 0. And you have 2x equals 12 So x equals 6. Okay? And the next row says plug in 3 for x. So this time we're going to plug in 3 for x. So 2 times 3 minus 3y equals 12. So we're going to solve for y. 2 times 3 is 6. Minus 3y equals 12. And of course, we got to solve for this y. So this is why we learned how to solve equations. We're going to subtract 6 from both sides. That gives us negative 3y equals 6. Divide by negative 3, y equals negative 2. And you're just going to continue on down the chart this way. I'm just going to fill in the answers. So pause the video here, work out the rest of these, and then you can restart the video and see what the answers should be. All right, so for the rest of these, we're going to have when y equals 2, x equals 9. When x equals negative 3, y equals negative 6. And when y equals negative 1, probably had some difficulty with this one because this one turns out to be a fraction, 9 over 2. Or if you turn this to a mixed number, that's 4 1/2. All right, so these are going to be the ordered pairs that are solutions for this equation. 0, negative 4, 6, 0, 3, negative 2, 9, 2, 3, negative 6, and 9 halves, negative 1. All right, so the next part of this says to graph the points from this previous example. See, these are the same equations here. So we're going to graph these points on this line, and if we did everything correctly, all of our math over here is good. These ordered pairs should make points that line up in a straight line. So I'm going to have to there we go. So let's see. The first point is 0, negative 4. So that's going to be here. Actually, no. I put it in the wrong place. That will be here. And then 6, 0 will be here. 3, negative 2 will be here. And it looks like they are lining up. 9, 2 will be up here. 3, negative 6 well, that doesn't line up, does it? Oh, it's negative 3, negative 6. It's supposed to be a negative 3. My mistake there when I wrote it. So, negative 3. 1, 2, 3. 1, 2, 3, 4, 5, 6. And it does line up with the others. It's down here. Right there. And 9 halves, which is 4 1/2, negative 1. So we're going to go one, 2, 3, 4, and a little bit. 4 1/2, negative 1, and it'll be right there. And it does line up with the others. There we go. So if you have a ruler, line them up with a straight edge. And don't forget to put the arrows on the end. You have to have the arrows. Your solutions are not correct if you leave the arrows off the line, because the arrows indicate that these solutions continue on infinitely in both directions, and of course they do, but geometrically, mathematically, if you leave the arrow off, you're saying that the solutions stop there, which we know that they don't. So don't leave the arrows off your lines. Okay, so down here at the bottom we have some definitions about linear equations. A linear equation is a first degree, which just means that the variable is only raised to the first power. There are no exponents on the variables. the graph is a straight line in the Cartesian coordinate system. Well, we've already discovered that. Linear equations are equations that can be written in the form ax plus by equals c, which is just saying that the x term plus the y term equals a constant, and this is what we call standard form, where a, b, and c are real numbers and a, b are not zero at the same time. So one of them could be zero, but they can't both be zero at the same time. So a linear equation can be written in other forms, such as slope-intercept form or y equals mx plus b, which we're going to talk about in a further lesson here. All right, so we have a few more equations here that we're going to work with. Here, y equals 2x plus 4. This time we have a table with nothing filled in. The previous two examples, we had some values to work with. They were already given, either x values or y values. This time we don't have any values. So that just means that we're going to choose some x values, find at least 3 solutions. So 3 is enough. Choose 3 values for x, and I will tell you this, it does not matter what values you choose. You're finding 3 solutions, and remember, there are infinite number of solutions. So if you're working this with a partner or a study buddy, you can choose 3 different values of x than your partner chooses. You'll find different solutions, but they should still line up on the same line as long as everybody did their math correctly. So I'm going to show you what values I like to use, but you can choose whatever values you want to work with. So I usually work with 0 for x because 0 is easy to work with. And then I choose a positive number and a negative number. And I don't usually use 1. I usually use 2 and negative 2 just because it spreads my graph out just a teeny bit. So then I'm going to take 0 and I'm going to plug it in for x, and I'm going to simplify and find out what y value goes with 0. So y will equal 2 times 0 plus 4, or 0 plus 4, which means when x is 0, y is 4. And then the same thing for when x equals 2. Y equals 2 times 2 plus 4, which is 4 plus 4, so y equals 8. And then y equals 2 times negative 2 plus 4, which is negative 4 plus 4, which makes 0. So there I have my 3 ordered pairs for this equation. And we're going to write them in right over here. So we're going to have 0, 4, 2, 8, and negative 2, 0. And you only really need 3. If you want to do another one, perfectly fine. You can do the 4th one if you like. Any value here, 1, negative 1, 3, negative 3, anything you want. It's going to give you another ordered pair that lies on the same line. So we're going to look at the graph here. Let's see if I can zoom in the graph. So we're going to zoom in the graph. All right, the first ordered pair on our chart was 0, 4. So 0 and then up 4. That's going to put it right about here. That's 0, 4 right there. The second ordered pair was 2, 8. So to the right 2 and up 8. It's going to put it right there. The third point, and this is always the test to see if the third point lines up with these other two, was negative 2, 0. So negative 2, 0 is right there on the x-axis, and it does line up with the others. So use a straight edge, see if you can get a straight line. And don't forget to put the arrows on. All right, we have another graph and table down here toward the bottom. Let's just work on the table first. The equation is y equals 3x minus 2. So again, I'm going to choose the same values for x this is a different equation, so those values will give me different values for y, different ordered pairs, and a totally different line. So I'm going to choose 0, 2, and -2. Those are the values I like to work with. So I'm going to plug in first 0 for x. And here we go, we got some room over here. So y equals 3 times 0 minus 2. Well, 3 times 0 is 0. So it really just says y equals -2, doesn't it? And then I'm going to plug in positive 2 for x. So y equals 2, no, not 2. 3 times 2 minus 2, or 6 minus 2, which is 4. So y equals 4. When x is 2, y is 4. And then I'm going to plug in -2 for x. So y equals 3 times -2 minus 2. So -6 minus 2 is -8. So y equals -8. And those are the ordered pairs for this equation now. We have 0, -2, 2, 4, and -2, -8. And we're going to make those ordered pairs points on our graph. It should line up in a straight line. So the first one is 0, -2. So 0, then -2. That would be right here. 2, 4. So over 2 to the right, and then up 4 will be up here. Right there. And then -2, -8. So to the left, -2, and then down to -8 will be right here. And it does line up with the others. They're kind of far apart, but it does line up. That's right there. So this is going to be difficult to freehand because it's so steep. That's better. And again, don't forget your arrows. Okay, so I think this is the last one for this section. Yes, we have another new equation. 2x minus 4y equals 6. I'm going to fill in the table. So again, I'm going to use the same values for x that I used before. I'm going to use 0, 2, and -2. All right, so I'm going to take 0, plug it in for x. This is going to be a little more difficult because of the form of the equation. That's okay, we can still do it. All right, so it's going to be 2 times 0 minus 4y equals 6. So 2 times 0 is 0. So I have -4y equals 6. When I divide by -4 here, I do not get a whole number. I get 6 over -4, which when I reduce makes -3 over 2. And so we're going to end up with a fraction here. -3 over 2 is -1 1/2. In the ordered pair, we usually write it as an improper fraction, but it's beneficial to change it to a mixed number for graphing purposes. All right, so down here, I can't see the equation now. 2x minus 4y equals 6. So 2 times x, which this time is positive 2, minus 4y equals 6. So this would be 4 minus 4y equals 6. So to figure this out, we're going to have to subtract this 4 from both sides because we're trying to solve for this y here. That gives us negative 4y equals 2. We divide by negative 4, and we get another fraction, negative 1/2. So this time we have negative 1/2. So the ordered pair is 2, negative 1/2. Oh, so this time x is negative 2. So we have some room down here to write. So we're going to do 2 times x, which is negative 2, minus 4y equals 6. Okay, so that's going to be negative 4 minus 4y equals 6. We're going to need to add 4 this time. So negative 4y equals 10. Divide by negative 4, and we get another fraction, negative 5/2 when you reduce. So on the table, negative 5/2, which is equal to negative 2 1/2. So the ordered pair here is negative 2, negative 2 1/2. Let's write it as an improper fraction. Negative 5/2. Okay, now graphing this could be tricky because of all the fractions, but that's okay. We can handle it. All right, so here's the graph. All right, 0, negative 3/2, or negative 1/2. So that would be 0, negative 1, negative 1 1/2. It's going to be right there between negative 1 and negative 2, and you can't really be really accurate with the fractions on these type of graphs, so you're just estimating about where it is. Usually by the time you draw your point, you've taken up almost the whole box anyway. Positive 2, negative 1/2. So positive 2 first, negative 1/2 will be right there between the axis and the negative 1, so it's going to be right there. So right in there. Okay? And then negative 2, negative 5/2, or negative 2 1/2. So negative 2 this way, negative 1, negative 2 1/2, right about there between the negative 2 and the negative 3. And they do line up, which is always a good thing. If your points don't line up when you do this part, then you made a mistake with all that algebra figuring that we did over to the side, over here. If these points don't line up in a straight line, then you made a mistake over here, and you're going to have to go back and check your math. But that's basically how you use a table of values.